Hello, this is Dr. Bit Lavenu. In our today's session, we will discuss the conic sections part 3. In this session, we will see the how to create a hyperbola. In our last session, we have seen parabola and ellipse, different methods. But in our previous sessions, we also discussed some extent how to create a hyperbola, but in this session we will also discuss the hyperbola in different methods also some extent. Then we move forward to discuss uh, how to draw a normal and tangent to on a curve on, uh, on a point. Assume that there is a point and a curve like parabola, hyperbola and ellipse, and my intention is to draw a tangent and normal at that point. So that procedure we will see in this session. Then let me move further to see uh, hyperbola in this session. Uh, so then we will see hyperbola to a point of known coordinate systems. So this problem intention is to draw a hyperbola which is passing from a given coordinate point. Now I read out the problem here. Problem number 10. Point P is 40 mm and 30 mm horizontal and vertical axis respectively. Draw hyperbola through this point. As I said just now, my intention is to draw a hyperbola to a point of known coordinate point or the known coordinate system otherwise. The point is 40 mm and 30 mm horizontal and vertical axis respectively. But now please make a correction that 40 mm is horizontal and the vertical is 30 mm given here. But here in the animation that I'm going to show you, the 40 mm is along vertical axis and 30 mm is along horizontal axis. So please make a correction in this. 30 on the horizontal axis, the 40 on the vertical axis. In that way you take. Now draw x-axis, y-axis and x-axis. You can create an origin. Then locate a point in the coordinate system along x and y axis. The point is at 30 mm and 40 mm. 40 mm is on the vertical axis, as I said just now. In this problem is given 40 and 30 horizontal and vertical respectively. But here the 40 is vertical. So vertical, and read this sentence as vertical and horizontal respectively. So the vertical is 40, then horizontal is 30. Locate the point, then locate 30, then you will get a point at this location. This point is in the coordinate system at 30 and 40. 30 mm along x-axis, 40 mm along y-axis. Now the intention of this problem is to draw a hyperbola which must pass from this point. This point is at 30 and 40 along x and y axis respectively. Now divide this vertical line into 4 equal divisions or 5 equal divisions. Known equal, convenient equal number of divisions. So now the height is 40 here, height is 40 here. So I have divided this into 4 equal divisions. Then similarly you divide this horizontal length, that is 30, into known equal division. Say in this case I am dividing this 30 into 3 equal divisions. So now I am naming these points 1, 2, 3 and 4. Finally you have 4 here. Now I am dividing this 30 mm into 3. So 1, 2 and up to here it is 3. 1, 2 and up to here it is 3. I have divided this y-axis coordinate and x-axis coordinate into the convenient equal number of divisions. Then I extend a line from P. I take a pointer here now. Then I extend this point P along x-axis, along y-axis like this. Along y-axis also I have extended. Then draw the lines, draw the lines from point O. That line must pass from all these points up to this extended line like this. Draw a line which must originate from O and also which must pass from these points respectively up to the extended line of point P here. The constraint here is the line must pass from these points, and up to here we have to draw. So I am projecting these points on the horizontal axis. In turn, I am projecting these points on this horizontal axis. And similarly here also, from O and from this point 1, extend up to this vertical line like this. Then from O, and that line must pass from point 2 and up to extend that line up to this vertical extended line of point P like this. Now you will name all these points. So 1, 2, 3, and similarly this will become your 1 and this will become your 2. Now you drop the horizontal and vertical lines from these points. So now I am dropping a vertical line here and horizontal line from this line like this. I am dropping all the vertical lines like this. So 3 vertical axes. Then I am drawing a horizontal lines from these points. So you will get an intersection point here. And similarly from point 2 also, I am drawing one horizontal line up to here. So you are obtained one point here. And similarly from point 3 also, I am drawing a horizontal line up to this vertical line of point 3. Now you are obtained 3 points here. And similarly you repeat this step in this side also. Now you drop a horizontal line here and vertical line from this point. So now you locate these points like this. Now you come here, you drop a vertical line and drop a horizontal line here. So similarly you will get one point here, and similarly you draw a horizontal line from here, so you will get a point here, and you locate all the points. Then you join all these points as a smooth curve. You will get one curve, named curve. That name is hyperbola. Now you join all these points like this, you will get a curve, and that curve is a hyperbola which is passing from the given point. This is a very simple method to draw the hyperbola which is passing from the given coordinate point. This is how we are going to create a hyperbola which is passing from the given point. Now I am moving forward to see the hyperbola in a given diagram like this. I read out the problem. A sample of gas is expanded in a cylinder. A sample of gas is expanded in a cylinder from 10 unit pressure to 1 unit pressure. Then expansion follows the law PV is equal to constant. If initial volume being 1 unit, draw the curve of expansion, also name the curve. Is given a table also here. So form a table giving few more values of PV. Just we need to form a table. If pressure P is 10, right? V is equal to constant. Volume is 1. So the final pressure is 1 and initial pressure is 10 like this. Okay. Now, then PV is equal to constant. 10 into 1 is 10. Then 5 into 2, 10. Like this, constant value is 10 here. Then from these values, we have to plot the PV diagram. So pressure along y-axis, then volume along x-axis like this. You name the points. So divide this because we have the final pressure value is 10. Okay. Then I have located 10 points, equidistant points on the x-axis. And similarly on the y-axis also, I have divided and I have provided the 10 equidistance points like this. On the x-axis, 10 equidistance points. On the y-axis, 10 equidistance points are located. And after that, Then this is your volume and this is your pressure. Then you drop the horizontal line from the vertical axis point and vertical line from the horizontal axis point like this, 10 and 1. And similarly, you drop a vertical line from point 2 and draw a horizontal line from a point 9 on the vertical axis like this. Then you draw, first you have 5 point here. Okay, you take 5 point, draw a fifth point, then the second point like this, so you will get a point. Then fourth, you take fourth value and the pressure is 4, so draw a horizontal line and volume is 2.5 from here. So exactly from here we have to draw a vertical line. Then pressure is 2.5 here, exactly from here to draw a horizontal line like this. If pressure is 2.5 and volume will be 4 like this, and from the volume axis draw a vertical line to intersect the pressure at 2.5 kgs per centimeter square here. Then the pressure is 2 and exactly from here draw a horizontal line, and the volume is 5 and from here you draw a vertical line, you will get an intersection point. Then the pressure is 1 and from here you draw a horizontal line, then the volume is 10 and from here you drop a vertical line, and these two are going to intersect at this point, and locate these points like this. Locate these points. Then after locating these intersection points, then you join these points as a smooth curve like this. You will get a curve. That curve is nothing but hyperbola. This curve is known as hyperbola. This is a PV diagram. On the horizontal axis we took volume, on the vertical axis we took pressure, and is given the relation between pressure versus volume. PV is equal to constant, and we are assumed the values, and based on that we have plotted a graph between pressure versus volume, and this is a hyperbola, and this curve is a hyperbola. Now let us try to draw a directrix and focus method, drawing a hyperbola using general method. This method is also known as a general method. This is also using a directrix, means fixed line, and focus. The curve must pass from must start from the directrix, and it must pass from the vertex. We will see what is a vertex in this case also. Then using a general method we have to draw the hyperbola, because I read out the problem. Point F is 50 mm from A line AB. That means it is a fixed line. A point P is moving in a plane such that the ratio of its distances from F, means it is a fixed point, and a line AB, which is a fixed line, remains constant and equal to 2/3. So it's given eccentricity. So draw the locus of point P. So locus means joining the moment of that point is joined together. We will get a curve. That curve is nothing but the locus of point P with this eccentricity. Are the path traced by the point. If we join all the points, the path traced by point P is known as a locus of the point P. So let us see how to draw this. So okay, first you draw the vertical line. This is our fixed line AB. Then draw a horizontal line. Draw a horizontal line like this, and locate a focus point F, that is at a certain location, at a certain distance. You don't know the, of course in this case the focal point is given, that is 50 mm. So locate F point, focal point at a distance of 50 mm, and from AB line, and this point is nothing but focus. This point is focus, and this line is directrix. Fixed line and fixed point is known as directrix and focus respectively. Now divide this focus point into 5 equal divisions. First, 5 equal divisions. So because why I did 5 divisions means the eccentricity is 2/3. So that means we have to divide this into third, 5 equal divisions. Okay. So then locate the vertex point on this. V is at a distance of 2 locations from AB or 3 locations from F. Like this, you locate vertex point V, then draw the draw the vertical lines to a convenient distances like this. So draw a vertical line like this first. So this vertical line. So the eccentricity is 2/3. Okay. So that means 2/3 is multipliers of 2/3 is 20/30. Then 30/45, 40/60, 50/75, so on. Okay. So then, so this is our vertex point. This is at a distance of 20 from directrix, 20 from the directrix, okay, and up to here it is 30. Up to here it is 30. So now our vertical line is at 30 mm distance from the directrix. Then take 30 mm. So this is our 30 mm line, okay. So then the ratio is 30 on the focal point or the focal line, then 45. Take 45 mm radius in our compass. Take 45 mm radius in our compass. With F as center, locate the points on this vertical line. Locate the points on this vertical line like this. Then, so you will get an intersection point here. Then you will get another intersection point on the bottom of focal line. So this is exactly 45. And as I said just now, this vertical line is at a distance of 30. And you take 45 mm radius in the compass. Then F as center, intersect this vertical line like this, up and down. Then you take 40 mm line, and this line is at 40 mm distance from AB. Then take 60 mm radius in compass with F as center. Then intersect this vertical line at top and bottom respectively like this. You will get 2 points on this, 2 intersection points on this line, which is at a distance of 40 mm from the directrix. Then draw one more line that is at 50 mm exactly, which must pass from focal line like this, focal point, and take 75 mm radius in compass with focal point F as radius, F as center. Then intersect this line, this vertical line, which is at a distance of 50 mm from AB line. Then intersect 2 points like this. So then locate the points like this. Then join these points as a smooth curve like this. Join these curves as a smooth curve like this. You will get a curve, overall curve. This curve is nothing but an hyperbola, the directrix and focus method. This is what the directrix and focus method. Let me move further to see the different how to draw tangent and normal to an ellipse. Okay, so which must pass from a point. So tangent and normal to a point, and we need to locate. We need to draw a tangent and normal to a given curve, which may be ellipse, parabola, or hyperbola at a given point on that curve. This is the objective. The problem is that to draw tangent and normal to the curve from the given point on that curve. Now let us see how to draw a tangent and normal to a given point on the ellipse. So you have an ellipse here. So we have a point at this location. Now you see we have a ellipse here, on this ellipse we have a point. So on this point I need to draw a tangent and normal at this point, and the tangent and normal must be at this point. This point should lie on this curve, so that curve is ellipse. Now we join F1 and F2 of this point P like this. So you have a point Q on this curve, on this ellipse. Assume that there is a point Q on this ellipse. Now join point Q, F1 and F2 like this, F1 and F2 like this. So the point need not be here, it can be anywhere else on this ellipse. So from that point, join two focal points of the ellipse like this. Then bisect this angle. So then we have to bisect this F1Q F2 angle. So after bisecting this angle, then draw a perpendicular line to this line, bisector, angle bisector we have here, which is FQF2. Then draw a vertical line which is perpendicular from this point, from this angle bisector, and this will become the tangent to this ellipse. So we have an angle bisector here, and to this angle bisector, draw a perpendicular line, and that line must pass from this Q in such a way that we have to draw this line which is perpendicular to this angle bisector, that must pass from Q. Now this line will become the normal to this curve which is passing from the given point, and this line will become tangent to this curve which is passing from the given point. This is what drawing tangent and normal to a point on the ellipse. I repeat this once again. We have ellipse here, we have ellipse here. My intention is to draw a normal and tangent to a point on the curve. Here the curve is ellipse. Now take a point here. I am naming this point as Q. Now you join this point Q with two focal points like this. After joining focal points F1 and F2 from this point, then draw angle bisector for F1Q F2. After drawing this angle bisector, then draw a normal to this angle bisector from point Q like this. Now this angle bisector will become normal to this curve, and normal to this angle bisector, this will become tangent to the ellipse in this case. So now we have drawn a normal and tangent for from a given point on the ellipse. This is what the procedure to draw ellipse, to draw tangent and normal from a given point on the ellipse. Now let me move further to C. So I take one more problem here, to draw tangent and normal to the curve from the given point. Okay, now let us see. So we have ellipse here. Okay, in this case we have directrix and the focus point, then we have vertex here. Okay, so this is a general method to draw the ellipse using directrix and focal point method. Okay, so you have vertex point and focus point, and you have curve here, so on which I am going to assume one point. So this point I am assuming. My intention is to draw a tangent and normal to this point, to this curve, and the tangent and normal must pass from this point. This is the objective of this problem. Now locate this point. I'm naming this point as Q. Then join Q and F. So after joining Q and F, now draw a perpendicular line to this Q. Draw a perpendicular line to this FQ up to directrix, just like this. So I am going back again. This is our point. This is our point Q on this curve. My intention is to draw a vertical line, that means normal and tangent to this curve, and the normal and tangent must pass from this point. Then to draw normal and tangent at this point, which is lying on this curve, so now you joined focal point F and Q like this. Then draw a perpendicular line to this FQ line. Draw a perpendicular line up to directrix. So just simply from here 90 degrees, draw a line up to the directrix. Then from the directrix point, draw a line from point Q. This line need not pass from vertex. It can it can be right side to the V, or it can be left side to the V. Now, after drawing a line from the directrix intersection point, which must pass from Q, then draw a perpendicular line to this tangent like this. So this will become normal and this will become tangent to the ellipse, which is on the ellipse curve. So this will become tangent, this will become normal. So this will become your tangent and this will become your normal. NN is your normal and TT is your tangent. Now let us draw the tangent and normal to the parabola. So ellipse we have drawn for general method as well as the other methods also. We have two focal points. So for those two focal points, so we have drawn the tangent and normal, even using the directrix and the focal point. Fixed point also, we have seen how to draw the tangent and normal. Now let us see the tangent and normal for the parabola. So I take one more problem here. I read out this: to draw a tangent and normal to the curve from a given point. So now I'm taking the curve parabola here, parabola. So the eccentricity is exactly 1. So that means this distance and this distance, VF and V up to this point will be same. Now you have focus point. Then we have fixed line, AB, directrix. Now let us see, in this case, you take one point on this line, on this curve. So I'm taking a point on this curve. I'm naming this point as Q like this. Now you join focus point and Q, focus point and Q. Then you draw a line which is perpendicular to this FQ up to AB line like this. Draw a line which is perpendicular to FQ up to AB line like this. Up to AB line like this. Now you draw a line from this point, so where this perpendicular line is intersecting at AB line. So from that point, draw a line which must pass from Q like this. Then draw a line which is perpendicular to our line, the previous line that we have drawn from the directrix location to the Q. Now you draw a perpendicular to this. This will become your normal and this line will become your tangent. This will become your normal. So, and similarly, how to draw tangent and normal to the hyperbola. Now let us see, take an hyperbola. As I said just now, so the vertex lies just more than half to the left side in the case of hyperbola. Now let us see, take a point on this curve, take a point on this curve. So name that point as a Q. Then join F and Q. Same method, then join F and Q. Draw a perpendicular line to FQ up to directrix. So this line will intersect at this location. And from this location, draw a line which must pass from Q like this. So draw a line which must pass from point Q like this. Then draw a perpendicular line to this. This perpendicular line will become normal, and this will become your tangent. This will become your tangent. So thank you. So let me go back what I discussed as of now. So as of now, in this session, we have discussed how to create a hyperbola in different methods. Then how to draw the tangent and normal to the from the given point on the curve. The curve can be hyperbola, parabola, or ellipse. So now let me quickly go through what we have seen in a flash. This is our hyperbola. Now I'm flashly, this is your hyperbola, and for this line, for this curve, so we have a point on this. So this point is Q. Then join Q and F. Draw a line which is perpendicular to FQ up to the directrix, and from the intersection point of this perpendicular line at AB, then draw a line which is passing from Q, that will become your tangent, and draw a perpendicular to this tangent, that will become your normal. Now let me go back again. Then for parabola also, same method. For parabola also, as I said just now, the vertex is exactly at the half here, parabola, because eccentricity is 1. Then now let us see, take a point here, then Q, and join Q and F like this. Draw a perpendicular line to FQ up to the directrix, and from the intersection point of the directrix, draw a line, and that line must pass from Q like this. Draw a perpendicular line to this tangent like this. So you have drawn tangent and normal to the parabola also. Now let me go back. Let me go back to what we are discussed. And if it is a simple ellipse, now the same method. Now it is the same method, ellipse. So as you take point Q, then join FQ, then draw a perpendicular line to this FQ up to the directrix, then draw a line from the intersection point which must pass from Q and normal, and this will become your tangent, and this will become your normal. Now let me again go back, and this is also ellipse, and it is having two focus, and in this case, and F1 and F2. Then you have a point Q on this ellipse. You have point Q on the ellipse. Then join point Q and F1, Q and F2 like this, Q and F1, Q and F2 like this. Then you draw an angle bisector of F1, Q, F2. Angle bisector of F1, Q, F2. Then draw a perpendicular line to this angle bisector. So that will become your tangent, and this angle bisector will become normal at this point. This is your tangent, and this is your normal. Now let me go back, the hyperbola. So this hyperbola is, let us see, this is a directrix and focus method. I discussed this once again in this case also. So then draw a horizontal line, vertical line AB, then a horizontal line. In this case, in this problem is given the focal point F is at 50 mm from the fixed line, that is directrix like this. Locate a focal point that is at 50 mm. Then divide this into 5 equal divisions like this. Then name these points as 1, 2, 3, and locate a vertex point because its eccentricity is 2/3. So locate a vertex point that is at 3 distance here. Then draw the vertical lines from the points right side to V. Right side to V. So now this is a vertical line. So now the eccentricity is 2/3 and take the ratios 20 by 30, 30 by 45, 40 by 60 and 50 by 75 and so on. So in this ratio, I took some values. So 20, 30 is exactly at the vertex point 20 and 20 already we have a point here. Then you take 30, 45. So 30 line is at this location, draw a vertical line from AB. Then taking 45 mm radius in our compass with focal point F as radius, intersect this line. Intersect this line. You will get 2 points like this. Then draw a vertical line at 40 mm distance. At 40, this point is exactly at 40 mm distance. Then taking 60 mm as radius in our compass, F as a center, intersect this vertical line like this. Then take one more line that is at a distance 50 mm, take 75 mm radius in our compass and intersect 2 points like this. Then join all those points. Then join all those points will give us hyperbola like this. Now let me go back what we had discussed in this previous slide. Then hyperbola with a given relation. So in this case, we are plotted PV diagram. The pressure is expanded from 10 mm to 10 bar to 10 unit pressure to 1 unit pressure. The expansion is going to follow the law PV equal to constant. For that, we have some values here. If P value is 10, volume will become 1, then constant will become 10. Because he is given pressure is 10 and definitely volume should be 1 and this will be 10. And if it is 5, volume 2 to get 10. So this value should be constant 10. Now, because the initial volume is 1, P1, V1, initial pressure is 10 and final volume is 1. So 10 into 1 and finally you will get constant 10, 10 into 1. So in this ratio, we have to plot some values. We have to get some values. If this is 5, this will become. If this is 4, this will become 2.5. 2.5, 4, 2, 5 and 1 comma 10. Like this, we will get some relation. Now with these values, take volume on the x-axis, then pressure on the y-axis. Then divide this because the maximum value in the case of volume and pressure is 10. So take this 10 coordinate values on x-axis and y-axis like this. X-axis we are taking as volume and y-axis we are assuming pressure. So now you take, if pressure is 10, volume is 1. If pressure is 10, volume is 1. So we got 1 point. If pressure is 5, volume is 2. Then pressure is 4, volume is 2.5. Then pressure is 2, volume is 5. So like this we have some values and we will get some points. So by joining all these points, so we will get a smooth curve. That curve is nothing but hyperbola. Now let us see the previous figure also, directrix and focus method. And this is not directrix and this is a hyperbola to a given point. I go back to C. Then we have point P. So I read out the problem. Point P is 50 mm and 30 mm from horizontal and vertical axis respectively. Okay, but in this case, please make a correction. 40 is along y-axis and 30 is along x-axis. Then I move forward to draw a hyperbola which must pass from this point. So locate x-axis and y-axis origin point, then locate the point, so which is at 30, 40 like this, which is as 30 mm and 40 mm like this. Then divide the vertical length of this point, vertical distance of the point, to 4 equal distances or convenient equal distances. If we take more number of divisions, we will get a smooth curve, more number of points, and we will get a smooth hyperbola. Then the horizontal length into convenient equal divisions like this. So say in this case it is 3. So extend the line from point P along x-axis and y-axis like this. Then draw the lines from the origin point, and those lines must pass from the division points like this, 1. Then O2 up to the extended line. We have to draw the lines up to the extended line. Then draw the line which must pass from point 3 and up to this extended line, and similarly draw the lines up to at this location. Then name these points 1, 2, and 3. Then locate 1, 2 like this. After locating the points on the extended lines, drop the vertical and horizontal lines from the same coordinate, same located points. So just like this, drop a vertical line, drop a horizontal line from the respective points. So from the vertically divided division points, draw the horizontal, and from the extended line, drop the vertical line like this. So you will get the smooth curves like this. Then drop the vertical line, then draw the horizontal line like this. You will get the points. Then join all these points. Join all these points. So you will get a hyperbola from the given coordinate point. This is what drawing a hyperbola from the given point. So this is what we are discussed as of now. So from the front to back and back to front, we are created. We have seen how to draw hyperbola from the given point, then how to draw hyperbola from the directrix and focus method, then how to draw the normal and tangent to a point on the curve, which can be parabola, hyperbola, and as well as ellipse we have seen in this session. Then in the next session, I move forward to see the helix, then as well as cycloid of a curve. So we will see the different conic section, different geometric construction curves in the next section. So as of now, I have completed conic sections part 1, part 2, and part 3 now. In the next session, as I said just now, we will see the few more curves like cycloid and involute. In the next session, the engineering drawing is the first year drawing for all the engineering courses, and as well as this course is also common course in the engineering and as well as diploma level. The conic sections or the geometric constructions are very, very important to draw the mechanical components. If you are a mechanical student, this drawing is essential to learn. Then if you are a civil engineer, so this drawing will definitely help you to create the drawings for the buildings or the drawings for the bridges or whatever the construction. So this civil side drawing, civil engineering side drawings will also require the basic knowledge of engineering drawing. This engineering drawing is common for all the branches, so that it is not specific to any branch, any type, any engineering. It should be learned by everyone. So with this, I close this session. In the next session, we will discuss few more geometric constructions problems as I listed just now. So thank you one and all.